Hi, so this is originally going to be some presentation slideshow type thing, like the rest of my videos. I even made the whole slides. I finished it. Look at all this. And then I realized that what I was making was shit and it sucked, and I should never made that. Like look at this. Do you understand this? No, you probably can't. I'm like Jared Lee Lochner, you know, the guy who shot up at that political convention. This type of shit he would make, okay? That's not cool. So yeah, I was told by my conscience actually that for the betterment of humanity, I'm just gonna make this a live commentary. So see you then.
Alright, here we are. There's a lot to take in here. Don't expect much editing, other than the sweet background music. But anyways, I just want to say what's going on here. You know, obviously you know the correct answer from the thumbnail. What's actually going on here? Well, here's the thing. We know this is going to be some polynomial sequence, right? But the idea here is you want to split it into its terms. And how do we do that? Well, we take these guys. These guys are the difference sequences. Now, this is a third degree term, and if you've watched big derivatives, you know the power rule is whatever, you know that this guy, this difference sequence, is going to be 1 degree lower. It's going to be second degree. And this guy is going to be 1 degree lower than that. It's linear, as you can see, and so this one will be constant. Now you can work this backwards to say, well, hold on, if the third difference sequence is constant, then the original sequence must be third degree, and that's exactly what we have here. We plug it in, as you know, repeatedly applying the power rule grants you this little factorial here that you have to divide by to get the actual coefficient. But now we have this term. This guy's sorted. What about the next one? Well, we want to get this one to the front. We need this to be the leading term because this guy sort of dictates everything, right? You know, this second degree term would have already decayed to nothing by this step. It would become a constant and 0, which is it's just 0, you know. How do we do that? Well, we create this new sequence up here, where we subtract this term. So this B sequence right here is this guy over here, and as you can see, this 5n squared term is now the leading term. Of course, you wouldn't know this if you're just solving some random sequence, but that's what's going on in the background. So as you can see, you know, we take this first difference, it's a linear sequence. We take this second difference, it's a constant, which implies the original is a second degree quadratic. And then we do the same factorial trick, but easier this time. And then lastly, we have this guy, which is trivial because it's already a constant sequence. This guy, the C sequence, it's already a 0 degree difference. So, you know, you don't have to do anything. It's already a constant. I forgot to write this explicitly, but 0 factorial is just 1. So this works out. And then you plug everything in, and it works 100% of the time, every time. Also, I don't want any questions about why it's all in red. You know, you can figure it out. I believe in you. You know, we're smart. We're intelligent creatures. You know, we don't need multiple colors to figure out how to do math. All right, you know, that's just not necessary. Thank you for watching. I gotta go to bed now.